And welcome, everyone, to what I'm going to call WhiteBoard Weather School. For those of you that do not know, my name is Jeff Verszyla, and I have been a meteorologist since about 1994, so for about the last 26 years. Most of that time was a meteorologist on television in Pittsburgh, which is my hometown. I was born here, I was raised here, and outside of 4 years of college and a little over 2.5 years, or right around 2.5 years in South Texas, I have lived here my entire life. So I consider myself to be at least somewhat of an expert with regards to Pittsburgh weather, since I've lived through it and I've worked through it for the better part of the last, we'll say, 46 years or so. I, as I said, am a Pittsburgh guy. I went to grade school at St. James Catholic School in Sewickley. I was up through 8th grade, and then I went to Quigley Catholic High School in Baden-Beaver County for high school, and then on to Allegheny College in Meadville. And I do have a wife and 2 sons, ages 11 and 13, so I do teach them about the weather as well. And in my 26 years of experience, I have probably visited thousands of schools, talked to thousands of kids about weather, and I thought this would be a great opportunity with so many kids home from school and perhaps not all of you having assignments to do, a good way to learn a little something extra that can be useful in your everyday life and allows me to share my love and my passion of weather and meteorology with you. So hopefully you learn a little something. I'm sure there are kids on here as well as adults, and we'll try and cover some topics that will be useful to you. And if this continues, where everyone is still at home for next couple of weeks, maybe longer, we'll look about doing more of these in the weeks ahead. So everything is open to discussion at this point. So with that said, it is time for school. There's the bell. So let's get learning. And I have my pointer right here. There you go. There's my pointer, which I'm going to use to help you understand some of the things. Now, the first thing I thought we would start and talk about is a weather map. It's what each of us see on a regular basis. You have a map of the United States, and you have all these lines with geometric shapes on them. You have all these letters. What does it all mean? Well, let me show you what a basic weather map looks like, and then we'll try and explain just about everything on that weather map. Here's what you see when you see a weather map. Again, there are a lot of things to digest here. It looks like a lot of lines, a lot of letters, and a bunch of geometric shapes and colors. Now, on any weather map, here are some of the things that you can see. This big blue H, you have these red L's, you have these lines, the blue lines with the triangles on them, you have the red line with the half circles, and you have lines that have both blue triangles and lines and red half circle lines. So there's a lot to look at here. And then you have these lines in between. See these black lines right here? There's my pointer. See these black lines right here? You have those lines in between the letters H and L. So let's start with the letters H and L. These are what we call high and low pressure. Now, when I'm talking about high, I'm not talking about hi, how are you? Even though I like to say hi, how are you to everyone. We're talking about high pressure, as in H-I-G-H. And I'm going to show you what that means. When it comes to weather, I always say the H, the big blue H, that stands for high pressure, means happy weather. So the H not only stands for high, but it also stands for happy. So that's why we have a little smiley face, because that is the kind of weather that high pressure usually brings. Good weather makes people happy. The L, the red L, stands for low pressure. And it also stands for lousy, because that's the kind of weather that typically comes with low pressure, lousy weather. That's why we have the sad face. So when you see H, the weather's usually good, which makes people happy. When you see L, the weather is usually lousy, which makes people sad. An easy way to remember. Now, some of the lines that you see on a weather map, I've outlined them here for you. You have the blue lines with the triangles and the red lines with the half circles. The blue one is called a cold front, which means that the air behind this front is cooler than the air in front of it. This is the dividing line between cooler air and warmer air, and these triangles are always pointing in the direction that the cooler air is moving. Just the same here, the red line with the half circles is called a warm front, which means the air behind that front is warmer than the air in front of it. So I'll use an example. It could be 70 degrees here, and it could be 60 degrees here. And as long as this front's moving in this direction, the 70-degree air will overtake the 60-degree air. And if it's 70 here, maybe it's 50 here. And this is the line that divides the 70 from the 50. Cool front, warm front. Now, how about these lines that have both the triangles and the half circles? This is called a stationary front. Do you know what stationary means? Of course you do. It means not moving. If you're stationary, you're sitting still. If a front becomes stationary, that means it is sitting still. Basically, the air on either side of this is not moving in this direction toward the front. It is moving parallel, right next to it. So the cool air in this case would be moving this way, the warm air moving this way. So the air masses are not moving, which means the front itself becomes absolutely stationary. There's no movement of air masses. And the final one you can see, and you don't see this one too often, this is called an occluded front. And usually on a weather map it is represented by a purple line that has triangles and half circles both on the same side. The best way for me to describe what an occluded front is, and I'm going to use my hands for this one, if you have a cold front here and a warm front here. Right in here is where the warm air is, back here is where the cold air is. Now typically a cold front will move here and a warm front might move here. If the cold front catches up to the warm front, so maybe this front is moving faster than this front. This front maybe moves at 70 miles an hour and this one's only moving at 50. What happens if something's 70 and something's 50? This one is going to overtake this one. So when that process of the colder front overtaking the warm front occurs, you have this happening. It closes that gap, and that's called occlusion, and that's why it's called an occluded front. And that's represented on the map by that purple line. So this process of one front overtaking or moving faster than another front is called occlusion, and that's an occluded front. So that's some of what you see on a weather map and a simple explanation as to what they are. Now, let's dig a little deeper about high pressure and low pressure, because high pressure and low pressure are kind of opposites. As we said, one's a happy face, one's a sad face. That's opposite. You have black and white. You have up and down. You have good and bad. All opposites. That's what high and low pressure are. They are opposites of one another in the world of weather. And here's what that means. Take a look at this particular graphic. You can see the sun here, high pressure here, clouds here, low pressure there. We've covered that. Happy weather and lousy weather, all right? What happens with high pressure is when you have high pressure, the air typically sinks. And sinking, at least in an atmosphere, sinking air is what we call more stable air. There's no condensation or air rising, which causes condensation and clouds and precipitation. Sinking air is stable. That's why you see no clouds, and that's what high pressure does. Just the opposite, low pressure causes rising air. When air rises in the atmosphere, it cools, it condenses, you get clouds and likely precipitation as well. So high pressure, sinking air, low pressure, rising air. Clouds, precipitation here, sunshine, and very few clouds in a case of high pressure. And they also spin in different directions. High pressure spins in a counter, or I should say, a clockwise direction. So you know how a clock spins like this? High pressure spins clockwise, low pressure spins counterclockwise in the atmosphere. So they are absolutely opposites of one another in the world of weather. Now, again, here's a look at some of the fronts that we've already covered. The warm front, the cold front, the stationary front, and the occluded front. Let's take a look at what these all look like on a weather map with some designations to tell you what each of them are. Here's a weather map. Here's high pressure. You can see there's no precipitation around the high pressure area. Here's low pressure up here with an occluded front and a cold front, and we can see there is some precipitation here. Back here is a stationary front. Again, the air is not moving on either side. It is sitting and moving in a parallel position to the front. That's your stationary front. So all of these features you'll oftentimes see on a weather map, and how they move helps determine how weather changes. As fronts move, the colder air moves behind it. As warm fronts move, where's a warm front here? There's one, where's one? There's one all the way up here. It's behind the banner. As warm fronts move, the warmer air moves. As high pressure moves, the clouds thin out. As low pressure moves, the clouds move in. So all of these things, as they move across the country in either a north to south or west to east motion, help determine what changes are coming in the weather each and every day. One final thing I want to point out on this map, because this one says high winds right here in the center. As we said, high pressure and low pressure are opposite, so the closer they are together, we call that it's called a pressure gradient force. That's a big term. Basically, the difference between high and low pressure causes the winds to blow harder the closer they are. If they were further apart, the lines wouldn't be as tightly packed or tightly pressed together. The closer these two are, the greater the wind speed is between that pressure difference. So you're going to have some very high winds through here. And these lines are called isobars, or lines of equal pressure. Again, the closer they are, the higher the wind speeds are. So that's a look at cold fronts, warm fronts, stationary fronts, occluded fronts, high pressure, and low pressure. I understand that is a lot of information to take in. So hopefully you remember some of it, but that's the basic breakdown of a weather map. Now, I have some other things that I want to show you. It's just general information. I don't want to overload you with so much information that you forget most of it. So we'll move here in sort of little steps. I think the most basic thing is understanding a weather map and all the things that you see on it. Now, I should mention all of those things we talked about. The reason they move from west to east or north to south is all based on one thing: the jet stream. What a jet stream is, if you think of a river, we have a lot of rivers around here. Rivers, the water flows. The jet stream is a river of wind. Just think about that. It's a fairly thin area of high winds, and as the jet stream moves across the country, way high up in the atmosphere, it moves all these things along. Cool air masses, warm air masses, cold fronts, warm fronts, high and low pressure. So the jet stream is ultimately responsible for the position and the movement and how fast things move of cold fronts, warm fronts, high and low pressure. So the jet stream is always the key factor. How is the jet stream moving? All right, let's head over, and I want to show you some things about severe weather because we are getting into severe weather season. Spring, oftentimes in Pittsburgh, brings thunderstorms, and thunderstorms sometimes can be strong or what we like to say severe. But severe means certain things. Anytime it thunderstorms, that doesn't mean it's severe. You have to have certain criteria. Certain things have to happen for a thunderstorm to be classified as severe. So we're going to head over to the big whiteboard and check out some of these things. This is whiteboard weather, school day edition. Now, in terms of severe thunderstorms, the criteria that need to be met are wind speeds at or greater than 58 miles an hour. So if a thunderstorm produces 40 miles an hour, it is not a severe thunderstorm. It's a strong thunderstorm, and it's probably one that's going to get your attention, but until those winds reach or exceed 58 miles an hour, it's not a severe thunderstorm. Also, if a thunderstorm produces hail, the hail has to be at least 1 inch in diameter. If you get a thunderstorm that produces, we'll say, penny-sized hail, that is not a severe thunderstorm. It's a strong thunderstorm, but not a severe thunderstorm. So you need winds at or greater than 58 miles an hour. You need hail at least 1 inch in diameter. And also, if a thunderstorm produces a tornado, it automatically becomes a severe thunderstorm. So the three criteria for a thunderstorm to be classified as severe. Now, how about watches versus warnings? It's a great one to know. A watch versus a warning. This could be a tornado watch. It could be a severe thunderstorm watch. It could be a flood watch or warning. It doesn't matter what the type of watch and warning is because they all are classified the same. A watch, think of your mom or your dad making cookies. When you lay out, and I'm not talking about the kind of cookies you cut off from the Pillsbury roll. I'm talking about making them from scratch. Homemade chocolate chip cookies. Let's think of that. If you make homemade chocolate chip cookies, you lay out all the ingredients. The chips, maybe the butter. You lay out the ingredients you need to make the actual body of the cookie. So you lay out all those ingredients. That's what a watch is. It means all the ingredients are there. Now, when you put those ingredients together and you cook the cookies, bake them, getting them ready to eat, when you put those ingredients together and you get yourself a cookie, that's a warning. That means the ingredients have come together and you now have yourself a cookie. So a watch is the ingredients, a warning is the cookie. That's the best way for me to describe it. All right, let's check out a couple of other things. Thunder and lightning. Important to know here because we are going to see and hear thunder and lightning, or lightning and thunder, in the weeks and months ahead. And this is a look and listen sort of thing. This is a good way to determine how far away lightning is based on when you hear thunder. So look and listen. If you hear thunder, if you see lightning and 1 second later you hear thunder, that means the lightning occurred a quarter mile away. If you see lightning and hear thunder 3 seconds later, that means the lightning occurred a half a mile away. And if you see lightning and hear thunder 5 seconds later, that means the lightning occurred 1 mile away. So that's a good way to gauge the distance that the lightning occurred from your position. So that's lightning and thunder and how to determine the distance from where you are. It's always a good idea if you see lightning and hear thunder to go indoors. Don't wait outside. I don't care if it's a quarter mile away, a half a mile, or a mile away. It's a good idea to get indoors to stay safe. Couple more things for you. Hurricane versus tornado. This is just some information about the differences between hurricanes and tornadoes. because they are very, very different. They're both destructive. That's the one thing they have in common, but they have many differences in between, in addition to the size. Tornadoes very small, hurricanes very big. A hurricane forms over water. A tornado forms over land. And I'm not talking about a water spout. That's not technically classified as a tornado. One gets a name, hurricanes. Tornadoes do not. Also, tornadoes are short-lived, usually 30 minutes or less. So they have a short lifespan. Hurricanes last for days and weeks at a time, so they live much longer. Hurricanes get classified ahead of landfall. They get a category name, 1, 2, 3, 4, or 5. Tornadoes do not get a classification of EF 0 up through 5 until after they've already done their damage. So one gets classified before, another one gets classified after. And also, hurricanes cause tornadoes. So those are differences between hurricanes and tornadoes. That's just some weather information that's always good to know. So I hope that all made sense to you. Just good general weather information to have any time of year. Now, a couple more things before I send you on your way with your new weather information. First off, I wanted to answer some questions. I had some of you that wrote in specific questions that you wanted me to answer. And I had Jace, who's 5 years old. He asked, why is there Tornado Alley and why do storm clouds turn dark? Well, Jace, my friend, storm clouds turn dark because of the density of the cloud. There is so much moisture, precipitation within the cloud that it becomes dark and dense. So the color of the cloud would indicate the density or the amount of moisture within the cloud. Now, about Tornado Alley. It's an excellent question. It's an area of the country that is more prone to seeing tornadoes than other for a variety of reasons. This is where Tornado Alley is. You can see the pink shaded area that runs from Minnesota all the way down through North Texas. And the factors that come together in that area of the country are, one, cold, dry air that comes down from the northern Rockies. 2, the jet stream that comes across that part of the country interacting with the cold, dry air. 3, you have warm, dry air that comes in from the Mexican plateau across the southwest. And 4, you have warm, moist air that surges up from the Gulf of Mexico. If you notice on this map, arrows coming from different directions. One coming from this direction, one from this direction, one from this direction, and one from this direction. When you have winds coming from different directions, especially at different levels of the atmosphere, you know what that causes? Rotation. And that's why this area of the country is known as Tornado Alley. It is where those conditions come together more often than anywhere else in the country. So Jace, I hope that explains about Tornado Alley. Hayden asked me, how do you predict weather? Well, Hayden, if you've been paying attention, we predict weather using all the things that I just told you. Looking at current weather maps, looking at projected future weather maps, and how the jet stream will move cold fronts, warm fronts, high and low pressure, and the amount of moisture that will be available to some of the cold fronts, the warm fronts, and the low pressure. So we look at all those things, the current weather map, and then the future projected weather maps, and then we decide how fast things will move, and as a result, how the weather will change. We had a young gentleman, Sam, age 10, asked, how do supercells form, and do all supercell thunderstorms produce tornadoes? Well, Sam, I will tell you that fewer than 20% of all supercell thunderstorms produce tornadoes. Just because you have a supercell thunderstorm does not mean it is going to produce a tornado. Matter of fact, there's an 80% chance that it will not form a tornado. It's going to be a violent thunderstorm because a supercell thunderstorm by nature is a rotating thunderstorm. There's rotation within it, but whether or not it actually drops a tornado, there's only a 1 in 5 chance that that will occur. You need just the exact right conditions to get formation of tornadoes. Now let me show you what a supercell thunderstorm looks like. This is very exciting. Very exciting. This is what a supercell thunderstorm looks like. Perhaps you've seen these. They have that anvil top or the spiky top. Sometimes at the very top you have air that escapes the top of the thunderstorm. We're talking about 50, 60,000 feet up in the atmosphere. And you get this little area called an overshooting top. That's where the air is evacuating at the top of the thunderstorm. But within the body of the thunderstorm, you have what are called updrafts, which is air moving into the thunderstorm. You have downdrafts, which is air moving out of the thunderstorm. So you have upward and downward motion. You also have air within the thunderstorm. You can see winds coming in from different directions at different levels. That causes the rotation within the thunderstorm. So all this volatility and all this air moving in different directions with all the moisture creates a very violent thunderstorm, and occasionally it does spin out a tornado. Again, it only happens 1 out of every 5 supercell thunderstorms. But a supercell thunderstorm, otherwise known as a cumulonimbus cloud, does happen on occasion around here. But they are something to behold, for sure. All right, we're going to have to move along here. I want to wrap this up within about the next 5 minutes. Jefferson from Virginia asked if I've ever been storm chasing. I have, but I never was actually visualized a thunderstorm myself, a tornadic thunderstorm. I've seen supercells, but I've never actually seen a tornado. So there you go. Drew asked on Instagram, can rainbows occur during snow events? The answer is yes. Rainbows can occur during snow events. It's just they probably look a little different because you have ice crystals instead of raindrops, which the composition of the moisture, ice crystals or raindrops, sort of changes a little bit of the visual prism effect. But you can have rainbows during snow events. And one more we do have, talking about hail. Somebody asked, who was it? Sam, age 9, asked, how does hail form? What the hell is going on out there? Here's the way it forms. Hail formation. You have raindrops that get sucked into what's called the updraft of a thunderstorm. And they head up, up, up into the cloud. Now, as those raindrops head up in the cloud, it gets colder in that cloud. As a result, the water drops, the raindrops freeze, and they start through this cycle of up and down drafts. So they start moving up and down in this sort of manner in the thunderstorm. The stronger the updraft is, or the air moving up is, the longer these now ice molecules will circulate through the cloud. And every circulation adds a new layer to a hailstone. So the bigger a hailstone is, the more cycles it has gone through the cloud. When the hailstone becomes too big and the updraft, the air moving up, can no longer hold it, then it falls. It comes down through the downdraft. So hail is basically rain that rises up into a thunderstorm, freezes, and then recycles probably a few times through a thunderstorm cloud, through that sub-freezing air, adding a layer of water every time. And as a result, then it gets too big, and eventually, when it gets too big, the hail too large, it falls from the cloud. Gravity basically takes over. So that's hail. So if you ever see a hailstone, crack it open and see if you can see inside. There'll be rings. And how many rings there are within a hailstone indicates how many times it went through that up and down cycle in the thunderstorm. So those are some of the questions that you guys wrote in. I have one more thing I want to do for you. I'm going to have to call my teacher's aide. Shelly, Shelly, my teacher's aide, I'm going to need her because here's what I want to do. I'm going to do the weather alphabet. I'm going to take a few letters and I'm going to give you some weather terms that you may not have known that start with that particular letter. So we'll start today with A, B, C, and D. It is the weather alphabet, and I'm using my teacher's aide. Right there, everyone say hello to Miss Shelley. She's my teacher's aide. She's getting paid by the minute. Not getting paid that much. All right, you're going to have to flip the camera around. There you go. Now I'm going to jump over here. Here, hold this. Okay. Oh, where's my pointer? Okay, here's what we got, my friends. We have the weather alphabet. The letter A, and a word that you may not have known that starts with the letter A is anemometer. It's a tough one to say. Say it with me. Anemometer. What an anemometer is, it looks a little bit like this. It is a weather instrument that measures wind speed and wind direction. So the way we know which direction the wind is coming from and how fast it's coming is by using an anemometer. Another A word, atmosphere. That is basically the air that we live in. We live in the atmosphere. Now the atmosphere does have certain layers. We live in what's called the troposphere, the lowest level of the atmosphere, but it goes all the way up into space. B words, blizzard. This word gets used too much and it doesn't always apply. Anytime it's snowing real hard, people say, it's a blizzard out there. Not technically correct. In order for something to be a blizzard, you need sustained wind speeds of 35 miles an hour or greater for 3 hours or longer, and visibility reduced to a quarter a mile or less for 3 hours or longer. That is a blizzard. Because it snows real hard for 15 minutes, not a blizzard. 3 hours of winds, 35 or greater. Barometer. That is what a barometer might look like. A barometer measures air pressure. High pressure, low pressure. Barometer. C. Sí, señor. Little Spanish lesson today too. Hola, ¿cómo estás? C. Cumulus. Cirrus. Both are kinds of clouds. A cumulus cloud is a cloud of vertical development, which means it develops straight up. A cirrus cloud are those high, thin, wispy clouds that maybe sometimes you see really high in the sky. Two types of clouds, cumulus, cirrus. And finally, D. Dew point. It also stands for dad joke. Dad joke time. You know what the dew point is? It's the opposite of the don't point. Dun, dun, shh. No, the dew point is the temperature at which the air becomes 100% saturated or absolutely full of moisture. When you have a high dew point, it gets very humid. And also when the temperature and the dew point are virtually the same, if you have a 68 degree dew point and a 70 degree temperature, it's high humidity, and you also get stuff that looks like that. Dew that forms. Dew point. Opposite of the don't point. And much more. And finally, we have degree. Now we are not talking about the degree that goes here. Some people might use degree deodorant. Some people may have one of these. A degree from a university. That is not what we're talking about. A degree is the measure by which we use to get temperature. Thermometer measures in degrees. The Fahrenheit scale and the Celsius scale. Degrees. Fahrenheit we use to measure temperature in the United States. Celsius is used pretty much everywhere else in the world. That is your D word, degree. Not here, not here, but out there. That's your D word for degree. Thank you, Miss Shelley.
You're welcome.
All right. That is all I have for you with your ABCs of weather and all your weather information for today. As I said, we'll try and do this again next week. I'll keep you alerted as to a day and time. I hope this was educational and informational for you. Hopefully you, kids, got something out of this. Hopefully you, adults, got something out of this. And again, we'll try and do this again next week. So, with that said, school is out for the afternoon, at least weather school. There's the bell. That must mean school's over. Have yourself a great afternoon, everyone, and stay safe. Peace.